All right, so let's solve sort colors today. This problem is supposed to be the continuation and the next problem after move zeros. The approach is almost similar for the second and the third solution, especially the second one. So we're going to check into that. But before that, let's check out on the brute force solution. What happens in the brute force solution is that we will first iterate through the whole array once, hence it becomes O of n. Then we are going to assign a new array inside which we are going to keep the count of it, right? So that gives us space O of 1 because we'll need one more extra space, that is an array. So let's see how that works, like how does it work in action. See, like here's the new array. Then we're just gonna count it like one by one, see how many of them are there. We will solve the third one and the second one. We're not going to solve the brute force one. So the approach is mostly like first you will iterate through the whole array, then you will count how many like zeros are there, how many ones are there, and how many twos are there. Then we are going to place them in order inside that array. That in the zeroth indexed, where there are supposed to be zeros, we're going to count how many zeros are there in the original array, followed by the 1 and the 2, because the array that will be provided by the question will be in order of like 0, 1s and 2s. And then we'll just count it back, like so we'll just count that we have 3 zeros, so we are gonna put 3 zeros, 0, 0, 0. Then we have 2 ones, 1 and 1, and then we have 2 more 2s, so 2 and 2. So let's check out on the brute force solution that I have solved previously. I'm just going to show it to you guys. So this is the brute force solution. First, we will initialize an array. Then we'll do that part where we will uh, like try to spread the count inside the array. And this is for the overwriting part. Let's move on to the next better solution. So this one is a bit more interesting. We are going to solve this one. We haven't solved this one yet. So this is where this is like this problem sort colors is a next what's that called, approachable problem after move zeros, because this problem has almost the similar approach of move zeros. But what happens over here, we'll just first sort it out so that we have the zeros in the front and the ones in the middle, or at least have the zeros in the front, and then we'll do the same opposite thing for twos from the back side. First from the front and then from the back side. So let's see this algorithm in action. So we just initialize a write. So like this is a bug of the website which I've already reported. So it says that if ARR of I is equals to 0, what we are going to do, we are going to replace the write and I, and we just go for the write plus plus and I plus plus. Like I is always going to be plus plus because it's a for loop. So yep. Like at this point, we don't really care about the 2 or the 1. We just care about the 0. We need to put the zeros in order first. Then we'll go back and do it for the right. Like since the value of right is already 3, so we know that up until when we have to stop. So the I becomes the right. Like the value of I is right, which is this. This should be I guess. Yes. While I is less than equals to back. Looks good. So let's try to solve this one. So let's say we have given array ARR. We have a right, sorry, the spelling is right, whose value is initialized with 0. Then we write a for loop, right? For I, which starts at 0, goes till n minus 1, because we need to start from here and go up until the very end. Then what do? We say if ARR of I is equal to 0, we need to swap. Swap what? ARR of right, holy, and ARR of I. And what we need to do? We need to do right, right, plus plus. Like we need to increase the value of this. Looks good. So this should give us the zeros first. Now let's go for the back approach. We say for I, which starts from n minus 1, or let's just call this back because we'll start from here. Starts from here. Then we say we need an I whose value is going, I put the wrong symbol, whose value is going to be right. Why am I saying white? I'm just typing white. So what do we say? While I, is it I or the value of I, right? Yes. While the value of I is less than back, right? Because I will be over here and back will be over here. And we need to track the moment these two separate, we need to stop it. If ARR, why am I giving that? ARR of I is equals to 2, we need to swap ARR of I and ARR of back, and we go for a back minus minus, else we go for a I plus plus. We wrote something wrong. Return ARR. Uh, Did we write something wrong? Let's just copy this. What do you say? Oh yeah, like they just initialize. I wrote it Y. That's why I was a bit confused over there. So yeah, like this actually looks good to me. I said while less than equals to, and this is not a back. We just initialize it. So let's try to initialize it and see what's the result is. See, looks good. So let's keep on this and try to solve this problem. Description. Let's go to the code. What do we say? We say that let's just copy this code over here for fun. Eh, sorry, where's the note? Right, so we'll be needing this. So what do we have? We need to initialize a for loop for okay, before that we need to initialize a write. Let write is equal to 0. And what do we say? Let I is equal to 0 goes up until I less than, goes till nums dot length -1 I plus plus. Or let I is equal to 0, or I give it a comma, should be this. I'm writing a bit of Python, I'm getting confused. So what's next? We say that starts from 0 and goes up like up until here. So we say now that if nums of I, if that is equals to 0, we need to swap what? Nums of write and nums of I. We need to swap this. And to say I, and then we say write. Looks good. We swap this and then we go for a write plus plus. Write plus plus. Cool. This is the first iteration. Then what do? We will go for a back. We say let back is equal to nums dot length -1 and we don't need to let's say write. Let I is equal to write, while I is less than equal to back, right? We can just write this actually right, like we don't even need the I guess. We just write it right from here. Right. Okay. So after this, what do we need? We say that if the value of ARR is equals to 2, then we go for the swap, go for the back minus minus, else the I plus plus, which is the write plus plus over here. So if nums dot write, the value of this is equal to 2, then what do? We need to swap the value of I and the value of back. So we swap nums of write comma nums back is equal to nums dot back nums dot write. Then we need to go for a back minus minus, else we just go for a, then we go for a back minus minus, else we go for a write plus plus. Looks good. Then we just say return ARR. Do we really need to return ARR? I don't think so. I don't think we need to return. Yeah. So we really don't need to return that because this needs to happen like in place. So this is the result. Let's try to submit it. Okay, it's coming a bit wrong. Uh, Need to Google this, I guess. What we might be doing wrong. So it turns out we need to go for this, which is less than. Like we put on less than, that's why we need length. Else we need to go for less than equals. It's just that. Yep. So it works. So now let's go for the optimized version. So the optimized version is the actually the simplest one. All we have to do, we have to initialize a low first, followed by a mid, which also starts from zero. Both starts from zero, and we go for a high, right? And we calculate while the mid is less than equals to high. Then we calculate if the value of mid is equals to 0, we are going to swap the low and the high, and we're going to say that let's just up the low to 1 and the mid to 1 as well. Else, we like if the value of mid is 1, we are just going to skip it. Else, we know that it's a 2, which is high. So we need to swap the mid and the high, and then we just go for the high minus minus. Let's just see this in action in dark mode this time, because dark mode looks better. So let's try to solve this. We have a low which whose value is equals to 0. We have a mid whose value is equals to 0. We have a high whose value is n minus 1. Looks good. We are going to continue while the value of mid is less than equals to high. Cool. If now we say we have to first say that we have given ARR, else we don't know what the value of ARR is. If the value of ARR of mid is equals to 0, what do we need to do? We need to swap it. We need to swap the value of ARR of I and the ARR of, what is the arrow? Mid, I mean bracket, sorry. Then we need to go for a mid plus plus I plus plus. Else if ARR of mid, if the value of that is equals to 1, then we just go for a mid plus plus. Else this is a high value, like it will be 2, so we need to swap ARR of mid and ARR of high. Then just say high minus minus. This should be the algorithm. without being the variable I is used without being initialized or defined should be low instead. ARR of low maintain logic. Okay, so yeah, like we need to not say I, but we just need to say low. I said I by mistake. It needs to be low, right? This needs to be low. Let's try to solve this again. Ow. The swap operation for low and mid should be should have increment low after swap, not mixed with mid plus plus. The swap operation of mid and high is missing a closing parenthesis, which lead to a syntax error. The algorithm does not handle the case where mid is incremented after a swap with high, which can lead to infinite loop behavior. Ensure the algorithm maintains correct order operations. Okay, so let's check what are we doing. Okay, I'm just missing the parentheses nowadays. That's the whole error, I guess, at this point. What did they do? They also did the same, right? Yeah, it's just the same. It's just the same. It's actually just the same. Like I just missed out on the what's that called? The syntax. And then they just say it's a return of the ARR. And we missed it. Low is equals to 0. Mid is also equals to 0. Then we have a high, which is n negative 1. Then we have, before we have given ARR. This should be it. There should be no other problems. Should occur after mid plus plus operation. So where am I doing wrong? Oh, so they are just saying that we need to do for the low plus plus first and then mid minus minus. Okay, it's just that. But let's try to solve this now. Well, now that we know the solution of it, let's just go into the notes and try to paste it. This needs to be previous, then after. Before that, we have given ARR, low is equals to 0, mid is equals to 0. Then we have a high, which is n negative 1, right? So let's try to do that. Let low equals to 0, mid equals to 0, and a high, which is nums dot length negative 1. Looks good. Then what do we say? We go for a while loop. While mid is less than equals to high, then we say if nums of nums of mid is equals to 0, what do we need to do? If it is equals to 0, we need to swap it, right? So we go for like I'm writing swap. Let's just go for nums of low and nums of mid equals nums of mid and nums of low, right? Then we go for a low plus plus, then we go for a mid plus plus, right? Else if the value of mid is equals to 1, then we just need to skip it. We'll just skip it, right? Else we know that this is the 2, like this is the high value, so we need to do this. We just replace this with high, low and high, and we go for a high minus minus. Oopsie. Ah, this should be good. Let's prettify this. Okay, this solves, but for the sake of the dopamine, we need to get this one. Just for the sake of the dopamine, right? We cannot miss this. When we say return ARR, evaluate. Bingo. All right, it worked. Thank you for watching, guys. This was Sort Colors.